Hey folks, welcome back. In this video we're going to go over question 2 from the 2016 SQA National 5 Physics exam paper. So let's get started. Question 2 says a student investigates the resistance of a resistor using the circuit shown. So we've got a battery, variable resistor, resistor R and an ammeter. Part A says to complete the circuit diagram to show where a voltmeter must be connected to measure the voltage across resistor R. And there's 1 mark available here. Well, remember a voltmeter must be drawn in parallel with the component that you want to measure the voltage across. So it would look something like this. So notice we've got a capital V inside the circle to represent the voltmeter, and just make sure there's no gaps in your drawing. Part B says to describe how the student obtains a range of values of voltage and current, and again there's 1 mark available here. Well, there's a few things you could say here to get the mark, one of them being that you would change the resistance of the variable resistor. Or another thing you could say is to change the number of cells or batteries in the circuit. Part C says the results of the student's investigation are shown. So we've got a table showing the voltage across the resistor R in volts and the current in the resistor R in amps. And there's 4 values for each. And it says use all these results to determine the resistance of resistor R, and there's 4 marks available here. Well, to answer this kind of data handling or skills question, we want to show the following relationship for each row in the table. So because we're trying to find the resistance R, we want to show that V divided by I is equal to R is equal to a constant. So for each row in the table, we're going to take our voltage value and divide it by the current value to show that it's going to come out to roughly the same value of resistance each time, and that should show that the resistance is a constant. So doing that for the first row in the table, if you do 1.0 divided by 0.20 in your calculator, you'll get 5 ohms. Doing it for the second row now, you get 2.5 divided by 0.50, which again gives you 5 ohms. For the third row, we have 3.2 divided by 0.64, which again should give you 5 ohms. And lastly, 6.2 divided by 1.24, again will give you 5 ohms. And it's a good idea to state the final result, so we've said that voltage divided by current, which is equal to the resistance, is equal to 5 ohms. However, another way you could do this is to simply plot a graph of the voltage against the current I, but I think this way is quicker and also a bit easier. Lastly, part D says the student now replaces resistor R with a filament lamp and repeats the investigation. A sketch graph of the student's results is shown. So we've got voltage across the lamp in volts against current in the lamp in amps, and we've got a curve sloping up the way. And it says state a conclusion that can be made about the resistance of the filament lamp, and there's 1 mark available here. Well, you should remember that for the normal Ohm's law experiment where we have a resistor instead of a lamp, we should get a directly proportional graph with a straight line going through the origin. However, here we've got a curve sloping up the way, which is characteristic of a non-ohmic conductor. And because we've got a lamp with heat involved, then we need to think about temperature. So as the temperature in the lamp increases, that's going to cause an increase in the resistance of the lamp. So we could say that resistance is increasing or not constant or changing, because that's opposite to the case for ohmic conductors where resistance is a constant, where you get that straight line on the graph. Now another way to think about the resistance increasing is to think about the gradient at a tangent to this curve. So if we think about a straight line along this curve at this point, and then another straight line along the curve at this point, and then another straight line up here, the gradient will gradually increase and increase as you go up this curve. And since the gradient of the line on a voltage current graph gives resistance, then that would tell us that resistance is increasing. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.